Hey everyone, sorry I can't be there today, but I didn't want you to kind of get behind the rest of the classes, so I thought we'd try this and see how it goes. Make sure you take notes when necessary. Of course, you should be filling this in on the packet that you received from the sub. Before you do that, check your homework with somebody else within the class when you get the chance, just to make sure you're okay with that. We're going to do two more examples with our slant asymptotes and graphing our rational functions, and then we're going to go over adding, subtracting, multiplying, and dividing rational expressions. After you get through this video, then go back through the packet and just work through um, all the problems that are in there. Some of it is on your graphing irrationals, and then there's some classwork on there with simplifying. And so you've probably seen the simplifying before, but I just kind of want to review it with you one more time. So this is the first one we're going to do. So when you get a chance, or so right now, write down in the front x squared minus x minus 2, and underneath x minus 1. And so I'm going to kind of work through this one at a time, and then have you try the next one, and then check your answers. So just to review your steps, you first want to start by simplifying. So you take that first one and you're going to factor it, and that factors into x minus 2 times x plus 1. So what I see is that there's nothing canceling. So at x minus 1, I have a vertical asymptote. Since that's the only undefined piece there, that means we don't have any holes because we don't have anything else. Then we're going to go through and compare our numerator and denominator degrees, and I see that the numerator is greater than the denominator, and since that happens, we don't have a horizontal asymptote. Since we don't have a horizontal asymptote, that means we have a slant asymptote, unless this was a special case. But since this doesn't simplify down to a linear equation, we don't have a special case. So we're going to divide. So let's divide our x minus 1 into x squared minus x minus 2. And so we think, what do we multiply x by to get to x squared? And the answer to that would be x. When you multiply x through x minus 1, we get x minus x. And all of that cancels out. And what we're left with is a remainder, which we don't care about anyway. And so we just have the single expression y is equal to x. So that is our slant asymptote. That's the equation of line that we're going to draw. Next, we move on to our x-intercepts. So as a reminder, that's where the numerator is equal to 0. So in this specific example, that's where this top one, x minus 2 and x plus 1 is equal to 0. And so there are two values there, positive 2 and negative 1. So we've got two x-intercepts. And then we have a y-intercept. That's when we plug in x is equal to 0. When you put 0 at the top, it would be 0 minus 2, so we get negative 2. At the bottom would be 0 minus 1 to get negative 1. And so this is going to simplify down into 0, comma 2. Our domain is everything except for 1, so negative infinity to 1, and then 1 to positive infinity. Let's start drawing in our vertical asymptotes and our slant asymptote. So here's your vertical asymptote at x equals 1. We have the slant asymptote of y equals x. So it starts at 0, 0 and goes up 1 over 1. I'm doing the best I can on a PowerPoint here, so you can do it a lot better. I know it's a little bit above the points over here, and that's okay. So then from there, we're going to graph our x and y intercepts. So I've got the intercepts at 2, comma 0 and at negative 1, comma 0, and a y-intercept at 0, comma 2. So I'm going to do the right-hand side to get a couple of points. I'm going to start with 3. And so when you plug 3 back into this equation at the top, it would be 3 squared, which is 9, minus 3, which is 6, minus 2, which is 4. And at the bottom, we'll do 3 minus 1, which is 2. So I have 4 over 2, which simplifies down to 2. That's a nice point to plot. So then we're going to do a different one. We need to do one that's to the left of the x-intercept here so you kind of get an idea of what it looks like. Unfortunately, we are going to have to do a decimal, so we're going to have to do 1.5. So when we do it at the top, 1.5 squared minus 1.5 minus 2 is negative 1.25. And then 1.5 minus 1 is 0.5. When we divide, I know it's about negative 2 point something because 0.5 goes into 1 twice. So I don't care the exact decimal. I just know it's negative 2 point something, which means it's between negative 2 and negative 3. And that's good enough for us. And then we're going to do the right-hand side. Since I already got two of these here, I'm going to go for negative 2. If you want to do 0.5, you can. Feel free. You just know it's going to go up against here anyway. So we're looking for 3 points, really. So if I'm here at negative 2, I'm going to, oh, sorry, connect the dots. On the left-hand side, and again, sorry about my lovely drawing abilities on the computer. So we're going to go ahead and plug in -2. When you do that at the top, you get 4. Underneath, you get -3, which I know is about -1.3 repeating. So somewhere around there is good. Anywhere between -1 and -2, as long as it's not touching the line. And then do the best as you can with drawing it in, and that's good enough. All right, so hopefully you got that drawn in. I'm going to move on to the next example. I'm going to have you pause and try to do this one all by yourself. So go ahead and give yourself a chance. So let's see how you did. Let's check your answer. I did this one on Desmos because it would be a lot better looking than the one that I could draw. So we have a vertical asymptote at x equals 1. We have no holes or horizontal asymptote. When you did long division, you do get, excuse me, y equals x plus 1. We have an x-intercept. Oh, we don't have any x-intercepts because there's no value. That's not true. Okay, so now I got that fixed. So you do have two x-intercepts. It is not a whole number, which is okay. When you solve for that, you have the square root of 2 and negative square root of 2, which is somewhere between 1 and 2. So it's 1 point something and -1 point something, and you can see that that is right here and right here. We have the y-intercept of +2, and then you can start plugging in points, but this is the general way the graph looks. So half of your homework, or a big chunk of your homework, is going to be doing more of these types of problems here, okay, where you're just graphing. The other half is going to be on simplifying or adding and subtracting rational expressions. And so what we're going to be doing is using what you already know about fractions. And so the problems are going to look like this, where you're going to have rational expressions times by each other. So what I want you to kind of think about is your fractions with just numbers. So if I have 1/2 times 4/3, I'm going to go through and simplify this first before I multiply through, because that is the easiest way to simplify, is always simplify before you multiply. Then you don't have giant things to worry about, especially when it comes to rational expressions. So for example, with a multiplication problem, I have a 2 and a 4. I can go ahead and simplify that right off the bat. And so instead of 2 and 4, I'm going to reduce that and divide out by 2. So when I do 4 divided by 2, I'm left with 2, and this essentially becomes a 1. So up top, I'm only going to do 1 times 2, which is 2, and on the bottom, 1 times 3, which is 3. Now, when you're doing division, you should have learned in the past to always flip and multiply. So instead, 4 over 9 is going to be times 3 over 1. And I'm going to do that same process. I see 3 and 9, they are one in the numerator, one in the denominator, so I'm going to simplify that. I'm going to divide out a 3. So at the top, it becomes 1, so I'm not going to change anything, but the bottom here, it's going to become 3. And now I'm going to multiply straight across. So at the top, I have 4, and the bottom, I have 3. The way that you work your rational expressions is the exact same way. I'm always going to simplify before I multiply. I'm just going to make things a lot easier because nobody wants to FOIL this out or anything like that. So let's go ahead and simplify first. If you want to multiply everything through and then simplify, feel free. Just trying to make it as easy as possible. So what you want to do is kind of make sure everything is factored. So I see I have m squared minus m times n, and there's an m in common. So I'm going to factor out a GCF in that bottom one, and I see it looks like this. And now I'm kind of looking around to see, do I have anything in the numerator that's also in the denominator? And I have a couple of things. First, I have an m at the top and the bottom here, and since this is a product, I can cancel it out. And then I have the quantity of n minus n down here, and I actually have two of them at the top. So what can happen is when I cancel one of these out, I'm essentially going to reduce this by 1. Well, 2 becomes 1. So it's as if the exponent isn't even there. The m at the top and the bottom are going to cancel out as well. So nothing else can cancel because I'm left with m minus 1 and m plus 1. Those are not the same. They have to be exact same signs to cancel. And so that would simplify down to that fraction. Applying those same rules for the second one, I've got that divide sign there, so I'm going to flip and multiply, and I'm going to reduce. So 5x plus 15, I'm going to pull out the 5, and I'm left with x plus 3. So a couple things can cancel here. I can see that the x plus 3 will cancel out with one of the x plus 3's up here. I see that there's a 5, two 5's actually at the bottom here, so I can kind of cancel it one at a time. So this 5 and 25 reduces the top to 5, and then both of those 5's will cancel. So really all I'm left with in this one is x plus 3. So as you can see, by simplifying in the beginning, before we do any multiplication, I'm getting rid of a lot of stuff, opposed to going through and multiplying everything out. Again, it doesn't really matter. So if you want to multiply through and then simplify, feel free. We also are going to add and subtract. So let's kind of review what we did. We find our common denominators. So the least common denominator between 5 and 4 is 20. And so what we need to do is multiply the top number and the bottom number by the same number. So in order to get 5 to become 20, I have to multiply by 4. So top and bottom is going to get multiplied by 4. Same thing on this side, I needed this to multiply by 5. So top and bottom is going to get multiplied by 5. So I end up with 16 over 20 minus 15 over 20. And then I can just go ahead and combine my numerators. So 16 minus 5 is 1. Same thing with the addition problem. So for this example, this one here, I need this least common denominator is going to be 12. So I'm going to multiply this whole fraction by 4 and this whole fraction on top and bottom by 3. Well, it didn't. Where'd it go? There you go. And so we can go ahead and just combine our numerators. 4 plus 3 is 7. The same thing is going to happen with our guys at the bottom. To find that least common denominator, we factor it and take the product of all the unique factors. So for example, in this one, the one on the left factors into x plus 3 times x plus 1. The one on the right is x plus 3 times x plus 7. The least common denominator would be x plus 3 times x plus 1 times x plus 7. We don't want to do this twice because they both already have it. So when we're doing our adding and subtracting, we're looking to have a least common denominator. This already has it. They both have y squared plus 3y minus 10. So therefore, we can just go ahead and combine the top. So the top will combine to 3y minus 6. Like common fact things can come together, like terms can come together. But at the bottom, it's just going to stay as is, just like in the previous slide with the 20 and the 12. So our next example is where we don't have common denominators. So what you want to do is factor each of them. So x squared minus x minus 6 factors into x minus 3 and x plus 2. The second one on the right there factors into x plus 3 times x plus 2. So as you can see, this guy is missing an x plus 3. This one is missing an x minus 3. So what you're going to do is multiply the top by x plus 3 on the left, and then the bottom with x, or the right one with x minus 3 on the right. And then I'm just going to simplify this through. So 4 times x plus 3 is the same thing as 4x plus 12. X times x minus 3 is x squared minus 3x. I'm going to add everything together, and so I end up with x squared. 4x minus 3x is x, and I bring down the 12. You might need to know how to multiply everything out as well, so make sure you know how to multiply this out, as that could be something like in a multiple choice where you need to be able to recognize that this is the same thing as that. One more example, and then we're all done, and you can start working on your classwork homework. So if we have a problem like this where we have our lovely little singleton, like where it's just minus 3, we still need to find the common denominator. So my advice, for those of you who don't recognize it, you're going to have to change that into a fraction. You can do it by putting over 1. So this is nice and easy here because the common factor here, this has a 1, so I don't have to multiply these by 1, but I do need to multiply this side here by 2x minus 3. So that's what I'm going to do next. Multiply top and bottom by 2x minus 3. And when I distribute through with the 3, I have 6x minus 9. And then I can have the same denominator, so I can go ahead and subtract. And I end up with negative 6x plus 16. Again, that's because that minus there, that's double negative. So we're going to end up adding those together. If you can simplify this. In this case, it's not going to simplify, but if it's possible, that's why I waited until the end to go through and multiply the denominators back together, because after you combine, you might be able to simplify something out. So always keep that in mind. You always want to simplify as far as you can. All right, so now that we're done here, I want you to go through and work on your homework. Try to really work through at least the ones with the graphing rationals. And next block, when we get back together, I'll kind of review this with you, make sure you're good. You probably saw this last year. We're just kind of reviewing it with you one more time. So I will see you in next block. Please finish that work, bring it all to class, and have a great day.